In 1996, Nvidia had only 30 days of cash left. Their first product had flopped so badly that nearly every unit was returned. Their biggest partner had abandoned them. And the company was so broke, CEO Jensen Huang literally dimmed the office lights to save on electricity. Silicon Valley laughed. Intel dominated. Nvidia was one breath away from collapse. But today, Nvidia is worth over $4.2 trillion more than Apple, more than Microsoft, and more than the GDP of 185 countries. It powers everything from OpenAI to Tesla, from Amazon's cloud to Google's language models. It is the beating heart of artificial intelligence. So how did a nearly bankrupt chip startup rise from the ashes and become the most powerful company in the world? This is not just a tech story. It's a story of belief, of failure, of one man's ability to see what no one else saw. In 1993, 3 engineers, including a Taiwanese American named Jensen Huang, started a tiny company in Silicon Valley with one goal: make computers powerful enough to play real 3D games. At the time, PCs were boring. They were used for spreadsheets, Word documents, and maybe Minesweeper. But video games were changing fast. Games like Doom and Quake introduced gritty 3D worlds that pushed the limits of technology. But here was the problem. To run those games, you needed a gaming console like the Sega Genesis or Super Nintendo. Computers simply couldn't keep up. They lacked the specialized chips to perform billions of calculations per second. That's when Jensen had his first non-obvious insight. If they could build a chip powerful enough to handle real-time gaming graphics, it could be the key to the next generation of computing. Their first product was the NV1, a revolutionary chip that combined graphics, sound, and game controls into one. It was bundled with Sega's new game controller, and everything looked perfect, until Microsoft entered the picture. In 1995, Microsoft introduced DirectX, a set of programming rules for game developers. DirectX insisted that all games use triangles to render images. Nvidia's chip, it used curves. The result? Nvidia had built the wrong architecture. Game developers couldn't use it, and within months, their golden partnership with Sega collapsed. Out of the 250,000 NV1 chips produced, 249,000 were returned. Nvidia was left with massive losses and no viable product. Jensen cut costs. The company dimmed office lights. Electricity bills went unpaid. The team survived day to day as competitors laughed. Nvidia was down to just 30 days of cash. Most people would have folded. But Jensen didn't. Instead, he gathered his remaining engineers and said, "We're building one more chip and we're going to do it fast." But there was a catch. They had no budget to test the chip on real hardware, so they did something insane. They simulated the entire chip in software. They designed a complex 3D graphics processor entirely in code using a simulation environment and sent it to be manufactured without ever testing it physically. Now here's why that's risky. A chip isn't just a metal wafer. It's a microscopic city of over 100 million switches, thousands of pathways, and intricate logic gates. One error? The whole thing fails. And when you manufacture a chip, they don't make one, they make millions. But Nvidia had no choice. They sent it to the factory and waited. For 8 long weeks, the team lived in dread. Every morning they asked themselves the same questions. Did we wire it wrong? Did we miss a connection? Is this going to bankrupt us? Finally, the chip arrived. The team held its breath. They slotted it into a motherboard, powered it on, and it worked perfectly. The chip was called RIVA 128. It was powerful, smooth, fast, and game developers loved it. Nvidia sold over 1 million units in just 4 months, more than any rival chipmaker. But Jensen wasn't done, because he had another insight the world didn't yet understand. To the tech world, video games were a distraction, toys for kids, unworthy of serious engineering. But Jensen saw the math behind the madness. Gaming wasn't just fun, it was computationally extreme. Fast-paced, physics-heavy, high-resolution, no other task demanded so many calculations in real time. If Nvidia could build chips that survived the chaos of games, Those same chips could handle rockets, surgery simulations, scientific computing, and eventually artificial intelligence. In 1999, Nvidia launched the GeForce 256, the world's first GPU graphics processing unit designed for parallel processing. While CPUs handled a few tasks at a time, GPUs could handle thousands simultaneously. It was a revolution in computing architecture. And that's when Jensen placed the biggest bet of his life. In 2006, Nvidia invested nearly all its profits into building something even riskier than a chip, a software platform called CUDA. CUDA, or Compute Unified Device Architecture, was designed to let GPUs handle tasks far beyond gaming: scientific simulations, medical research, deep learning, autonomous vehicles, and more. The problem? The world didn't need it yet. There was no AI boom, no deep learning, no ChatGPT, no real demand for massively parallel computing. CUDA was like building the rocket engine before we even dreamed of going to space. For 6 years, CUDA sat mostly unused. Nvidia kept the faith, but critics asked, why waste money on tech nobody wanted? And then in 2012 came the miracle. In a quiet lab at the University of Toronto, 3 researchers, Alex Krzyzewski, Ilya Sutskever, and Jeffrey Hinton, were working on an experiment. They wanted to train a computer to recognize images to tell the difference between a cat, a car, or a hospital bed simply by looking at pictures. This idea was called deep learning, and it required 2 things: massive data and insane computing power. They didn't have access to a supercomputer. What they had was an Nvidia GPU powered by CUDA. They fed the model millions of images, and slowly, the GPU didn't just crunch numbers, it learned. The model, named AlexNet, entered the world's most prestigious image recognition contest. It didn't just win, it crushed the competition. The results were so astonishing, so far ahead of the field, that they sent shockwaves through the entire tech world. Suddenly, CUDA wasn't a wasted bet, it was the key to the future. After AlexNet, everything changed. Google began using GPUs to power better search and smarter translation. Facebook improved face recognition. Tesla used Nvidia chips to train its self-driving algorithms. OpenAI built what would become ChatGPT running on Nvidia hardware. Nvidia was no longer just a chip company, it was the infrastructure of artificial intelligence. In 2016, Jensen stood on stage and said, "AI is going to change everything." Most people smiled politely. Some rolled their eyes. But he was right. As AI exploded in year 2020, from generative text to protein folding, from robotics to voice cloning, Nvidia's chips became indispensable. And in 2024, Nvidia did the unthinkable. It crossed a market cap of $4.2 trillion. That's more than Apple, more than Microsoft, and more than the GDP of most of the planet. So how did this happen? Not by chasing trends, not by doing what everyone else was doing. It happened because one man saw what no one else saw. Jensen Huang saw the future hiding in a video game. He saw a chip not as a piece of hardware, but as a brain. He built CUDA before the world needed it, and he led his company through failure, rejection, ridicule, and into history. "Nvidia is my life's work," Jensen once said, "and I've loved every part of it." This isn't just a business story, it's a resurrection story.